This is up in Idaho. My family lives up there. This is a creek, the Indian River Creek, and this was a streamlined channel, and still some places that it is very straight, so they put bridges over it. But in some areas they were able to pull it back and meander it, slope the banks down, landscape them, create access points, and now it's a draw for the city of Caldwell, Idaho, that's trying to do an urban recovery, if you will, getting folks to come back to the city center. This one, Cheonggyecheon River, Seoul, Korea, gets a lot of airplay, right? Because imagine this. It's really beautiful, amazing, hard to fathom what that looked like before, but that's what it was before. It was a freeway overpass, right? This is an elevated causeway-type freeway, and these roads are still here, and the creek was under here. Same shot, right? Same buildings, mountains. And they open it up, and they've still got hard edges, but they got pathways that multiple functions, and these little crossing access ways, and they just stepped up to honor that system. And I was again just in China, in Chengdu, with this woman, Betsy Damon. And here's a park. This is a 6-acre living water garden park on this Funan River. And they basically brought in the whole community, and they take water from the river and they bring it up into a system of constructed wetlands. So they have plant-based wetlands, and they purify that river water that's not nice. You would not want to swim in here. And through plants and biology and bacteria and fungus, they purify the water, clean it up through a series of systems. These are all constructed wetlands here. And then it eventually ends up in these beautiful fountains and parks, and people get to go play in it and hang out in it and splash in it. And I went there a lot here just 2 months ago, and the park is full of people and full of kids. And this was just nasty, unswimmable river water, which still exists just 100 yards or 75 yards over there. But through design and architectural, landscape, interface, biology, constructed wetlands, they created the most coveted park in that city of 11 million people. Beautiful example, I think. And here's one that I just find really inspiring. A guy named John Todd. He's a designer. Look up Ocean Arcs International. Very well known for things called living machines that do black water and gray water cleansing using plant and biology-based systems. This was a funky canal, again, in a city in China. And what he did in this case is, because it's perennial water, he put a floating dock on the canal, and then on both sides of the canal, he hung these baskets with mesh and gravel and such material, and then put plants in them. And then he has pump systems. And basically they're just pumping the canal water through these systems that filters through back to the canal along the entire length. These are linear walkways. Talk about river walk. This is like walk on the canal walk. And they got this water from black, rancid, stinky, crankcase oil-looking muck into beautiful, clear water with no smell with 6 foot of visibility within the first year of doing the system. Now again, you may not have a canal that has permanent water in this, but bringing in wetlands, bringing in life, bringing in biology, maybe it's up on the sides of the channel, maybe it's in the parking lot edge like I showed you before the water ever gets to the channel. But how do we bring life back to the system to do the work? And so it leads me to what I call conservation hydrology. And I'm interested in a regenerative rehydration and receiving that rainfall, recharging, retaining, releasing it via slowest spread it, sink it mantra. And what's the water footprint? How do roads work, and how does wastewater work, and how do we do water supply off roofs and parking lots and rain gardens, and how do we reconnect that where I live? I'm trying to get that cold, clean, clear, copious water back to the fish by retrofitting human settlement to make it more economically viable and more livable for folks outside of the creek. So it's not a fish versus farmers, fish versus people thing at all. We're actually team members and collaborators. And in the whole new era of the green jobs, I want to see a lot of blue jobs. I want to see people out there. It's not just installing solar panels and weatherizing houses. Who's the native plant person who's doing the propagation, who's planting the stormwater gardens and the rain gardens and helping with the installation of the porous pavement? Or, like, those are all jobs that your all youth should be getting involved with. This is a massive job stimulus package at the watershed scale to retrofit every human settlement pattern to be hydrologically literate again. All right? So keep your eye on the prize. It's a fast-moving train out there. This is a lovely little hummingbird friend of mine. And hopefully you have a bit more to reflect on as we go through the next couple days. You've got a copy of this publication, Basis of Relations, so my contact information is there, and I thank you for your time.
You have time for a few questions to draw?
Do you have a formula of, like how much bacteria, fungus you put in, to create this living liver?
She's asking, do we have a formula for how much biology, bacteria, fungus you would put in to create the living liver? There are formulas for folks who are designing these systems that mostly look at the volume of, so you figure out how much water do you have coming in based on the rainfall and the size of the watershed and the flood event, like how much water are you trying to treat? And then you ask, well, what are the constituents? How much, what do I need to deal with here? Is the water really polluted or not so polluted? And then you'll design a system that has enough volume, cubic volume, to handle that flow over a period of time. And so it's not a formula that is on my head, but there are curves, if you will. The engineering community has these graphs, and they can understand if you need 5 days of residence time for that water to pass from here to here through a matrix, blah, 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 then they can tell you it needs to be this size by this size and have this shape to it. So there is a science to it. But the biology and the fungus, the way we do these systems is, after you get it built and everything, and you're planting it and you're amending the soils, bring in the best aerobic compost you can find. Go to that black mucky place, that stinky place, that muddy place, that estuary, that creek over here. Get a little bit of everything, swirl it in some water, and just huck it out there. And life's going to sort it out. And whoever dies is food for whoever lives. And it's a brutal game out there. But the systems, they will establish, and they'll train themselves. If there's a lot of oil in that system, the fungus and the bacteria, they'll train themselves to become oil eaters. It's just natural selection. And it's happening all the time. And there's a lot of data on this, people trying to look at the fate of things. Heavy metals is a really interesting challenge. And copper, I don't know, every time you put your brakes on in your car, a little bit of copper sheds off your brake pads. And it's in minute amounts in the parking lot, but it runs off and it can accumulate. So there are plants that are known as dynamic accumulators. There's some interesting folks looking at placing plants at the beginning of these systems to actually sequester the copper up into the body of the plant. And then can we harvest that back out? The Chinese have a wastewater system where they run polluted, they take photographic processing water. Back in the day before digital, when people developed photos, and they use silver iodide in the development water. So they would run that water through a series of water hyacinths. You know what water hyacinths are? They're these floaty little plants, and if you don't get frost, they live a long time. It can be problematic in some areas. Beautiful purple flower. If the water hyacinth has a long root on it, I can tell you for sure there's not much nutrient in that water. If it has a little bitty short root in it, just anytime you see water hyacinth, just go pick it up and tell me about the roots. And I can tell you about the constituencies of the water and how polluted or not it is. So they would run it through that water, and then they would take the hyacinth, put it in an incinerator, burn it, and then blow the ash away, and they got back 98% ore quality silver. Because the plant recombined this aqueous silver iodide molecule back to its metallic form, and they reclaimed pure silver, jewelry quality silver, back out of the pollution using biological wetland systems.